Hello everyone, how are you all? Welcome to EduSure's 50 Days 50 Topics program of UGC NET and JRF. Today is Mathematics Day and I will be discussing a very important concept, limits, for you people. Okay, so limits. So let us start the concept of limits. As the name suggests, it means something happening to something when we approach a value. Now, what are these some things over here? Okay, so for that, we have to calculate, we have to calculate limit of a function. We have to calculate limit of a function fx as x approaches a. Okay, now what does it mean? It means limit of fx at a, and it is also denoted as limit x approaching a. This arrow means tends to or approaching or getting closer to a fx. So this is the notation. So first of all, we have to learn the meaning of x tending to a or x approaching a. So a is a real number. So whenever we have a real number, it must be sitting on the real number line. So this is my a. Now, when I am on the real number line, there are only two ways of reaching a. Either I can reach a from its left hand side or I can reach a from its right hand side. So when I am on the left hand side of a, the numbers look like a minus h, where h is a positive number. And when I am on the right hand side of a, the numbers look like a plus h, where h is a positive number. So as h becomes smaller and smaller, h tending to 0 means h is becoming smaller and smaller. So as h is becoming smaller and smaller, these a plus h and a minus h will keep coming close to a. Okay. So now we define the left hand limit LHL, left hand limit of fx at a. So what I will do, I will be calculating the functional value at a point a minus h, where a minus h is on the left hand side of a, and then limit h goes to 0. That means I am coming closer and closer to a from the left hand side of a. Similarly, RHL, that is right hand limit of fx at a, this is equal to limit h tending to 0 f of a plus h. That means I take the functional value at a plus h. Where is a plus h? A plus h is on the right hand side of a, and then I make h very small so that I come close to a. So this is the right hand limit of fx at a. So what do you mean by limit of a function at a point a? So limit of a function, limit of a function exists at a if and only if the left hand limit at a is equal to the right hand limit at a, and this common value is denoted as limit x tending to a f of x. This is the concept of limit. So whenever we talk about limit of a function at a particular point, we talk about the left hand limit and the right hand limit, and only when they are same, we say that the limit exists and the common value is the limit of the function at that particular point. Now, this is the definition of limits. So the first type of question that you will encounter is you will have to check for the limits. Okay. So for example, you have a function fx is equal to mod x upon x when x is not equals to 0 and x 0 when x is equal to 0. So if somebody asks you what is limit x tending to 0 fx, now note that this particular function is changing expressions at 0. So I can write it as, so when x equals to 0, the function is 0. When x is negative, so when x is negative, we all know that mod x is equal to minus x. So therefore, mod x upon x will be minus 1. Okay. And when x is positive, we can see that mod x is equal to x. So mod x, which is x upon x, which will be equal to 1. So this is my function. So on the left of 0, it is minus 1. At 0, it is 0. At 1, it is, when x is positive, it is 1. So whenever we talk about limit at 0, we don't care about what is happening at 0. This is irrelevant to us. When we talk about limit of a function at a point, we talk in terms of left and right hand limits. Okay. So you can see that the left hand limit is nothing but minus 1. And the right hand limit is nothing but 1. Now the left hand limit and the right hand limit are not equal to each other. Now this is the left hand limit at 0. This is the right hand limit at 0. So since the left hand limit at 0 is not equal to the right hand limit at 0, limit x tending to 0 fx does not exist. Okay. That is how we talk about limit of a function at a point. Now, for example, we have another question where fx is equal to, suppose it is x plus 1, x less than or equal to 1, and it is x square plus 1, x greater than 1. Okay. Now, you can see that on the left hand side of 1, the function is something else, and on the right hand side of 1, the function is something else. So when we talk about the left hand limit at 1, it will be nothing but limit x tending to 1. Look at the left hand expression, which is x plus 1. And now put the value 1 plus 1, which is 2. And if we talk about the right hand limit at 1, so this is nothing but limit x tending to 1, right hand expression, which is x square plus 1. Now put x equals to 1, 1 square plus 1, which is 2. So in this particular case, you can see that the left hand limit at 1 is equal to the right hand limit at 1. And therefore, limit x tending to 1 fx is equal to 2, because that is the common value which we have obtained. So the first kind of question that you can encounter is check whether the limit exists at a point or not. If it exists, what is the value? So the first example told us that it might happen that the limit may not exist. And the second example gave us an example where both the right-handed and the left-handed limits came equal. And the common value, that is 2, was the value of the limit of the function at that particular point. Okay. So the next is how to calculate limits. Okay. So method of calculation, first is direct substitution. This is the most easy concept. What do you mean by direct substitution? That means you directly input the value. For example, if your function is fx equals to x square plus 1, simple, and somebody says, what is limit x tending to 2 fx? So this is nothing but limit x tending to 2, 2 square plus 1, x square plus 1, and then you put the value 2 square plus 1, which is equal to 5. So this is called direct substitution property of limits, and this holds when we do not get an odd form. What do you mean by odd form? An odd form is 0 by 0 form, infinity by infinity form, etc. Now, second is factorization. What do you mean by factorization? For example, you have to calculate limit x tending to 1, x square minus 1, x minus 1. Now, if you put x equals to 1 over here, you will get 0 square 1. So that is 1 square minus 1 divided by 1 minus 1, which is 0 by 0. And 0 by 0 is an indeterminate form. Okay. So in such cases, what you have to do, you will try to find out the common factors. So I can write the numerator as x minus 1 into x plus 1. and denominator I have x minus 1, cancel. So you put x equals to 1, now it is 1 plus 1 equals to 2. So in this example, you note that if I take this function fx, x square minus 1 upon x minus 1, f1 does not exist. F1 does not exist because when I put x equals to 1, the value was 0 by 0, which is indeterminate. So F1 is not defined. But limit limit x tending to 0, fx is equal to 2, which exists. So there is a case, or in fact, there are cases when the function is not defined at a particular point, but its limits exist at that point. Okay. So it is not necessary for the function to be defined at a particular point to have a limit at that point. Okay, it might happen, and this is an example. Let's do one more example of factorization. So we have a question which is limit x tending to 3, x4 minus 81, 2x square minus 5x minus 3. Now, whenever you encounter an expression, the first thing that you are tempted to do is to put the value. So put x equals to 3. So that is 3 power 4 minus 81 divided by 2, 3 square minus 5 times 3 minus 3. So this is 81 minus 81 divided by 18 minus 15 minus 3, which is 0 by 0. So now you are stuck in an indeterminate form. So what I can do is that I can write this as x square whole square minus 9 square. And I can write the denominator as this by splitting the middle term. Now this is a square minus b square. So a minus b, a plus b. And now let's try to factorize the denominator as well. Again, in the numerator, I can write this 9 as 3 square. So a square minus b square is a minus b, a plus b. Okay. So 2x, x minus 3. So I can factorize this. Now cancel the common factor. Now put the value. So the value is actually 3, not 1. So it is 3 plus 3, 3 square plus 9 divided by 2 times 3 plus 1. And that is how you're going to get your answer. So first is direct substitution. Second is factorization. Okay. Now what if you have, square roots under consideration in your questions? So let's do a problem. Like for example, if I have this limit x tending to 0, 3x, suppose you have a situation like this. So, when you put x equals to 0, you will get something like 3 upon 0 minus 1 upon 0. So this is like infinity minus infinity. Now, infinity minus infinity is undefined. We don't know what is infinity minus infinity. In fact, it is indeterminate. Okay. So we will have to write this particular expression in a way so that we can calculate it. So let's try to take the LCM. Okay. Now try to put x equals to 0. So 3 minus. So under root 9 is 3. So 3 minus 3 by 0, 0 by 0. So now we have 0 by 0 form. So let's try to sort it out. How? So we can see that, there is this expression. Let us try to rationalize this. Okay. So how are we going to rationalize it? We will multiply and divide by the conjugate. What do you mean by conjugate? There is a minus sign before the root, so we have to convert into a plus. So we will be multiplying and dividing by the same expression so that the expression does not get disturbed. So this is a minus b, a plus b. So this is a square minus b square, and then this is x root 9 minus x, 3 plus root 9 minus x. So this is 9 minus 9 minus x. So our task is to cancel the troubling factor. Okay. And it will be eliminated by doing these steps. So now you can see that I have an x in the numerator, which will cancel the x in the denominator. And when I put x equals to 0, now I will be having this as my answer. So this is 1 by 3, 3 plus 3. So this is my answer. So you can see that we have 0 by 0 form. So first we were able to factorize it in the first case where we could cancel common factors. Okay. In this particular case, we had to rationalize. So rationalization is also one of the method to calculate limits. Okay. Next is trigonometric limits. Now, what are trigonometric limits? There are certain standard notations. The most common are limit x tending to 0, sin x upon x equals to 1. And number 2, limit x tending to 0, tan x upon x equals to 1. These are called trigonometric limits. Now, how do we use them? For example, you have a question and it says, calculate limit x tending to 0, sine 3x upon 4x. So, if I put x equals to 0, I will be getting sine 0 by 0. Sine 0 is 0, 0 by 0. So, again, you get indeterminate form. So, all these methods are there to help you get rid of the indeterminate form. So, now I can write, you can see that limit x goes to 0, sine x upon x. So this x and this x have to be same. This should go to 0. So I have sine 3x upon 3x. I will write it like this. This 1 upon 4 I can take outside, and 1, 3 I have to bring here to cancel this 3. Okay. So now you can see that when x goes to 0, 3x also goes to 0. So this particular expression takes the value 1. It doesn't matter. If x goes to 0, 3x goes to 0. I have a 3x here, I have a 3x here, I have a 3x here. So it is going to be 3 by 4 into 1, which is 3 by 4. All right. Now another one. For example, I have a question like this. Limit x tending to 0, sine 3x upon tan 4x. So you can see that if I put x equals to 0, I'll get sine 0 divided by tan 0. Sine 0 is 0, tan 0 is 0. Again, we have an indeterminate form. So I want to come out of this indeterminate form. So let me try to use the trigonometric formula. So I have a sine 3x. So let us divide it by 3x and multiply it by 3x. Then I have a tan 4x. So let us divide it by 4x and multiply by 4x. Now this x and this x will cancel out. So 3 by 4 will come out. And now this particular limit will be 1. And this particular limit will also be 1 because x is going to 0. When x is going to 0, 3x is also going to 0 and 4x is also going to 0. Therefore, I can apply formula number 1 and formula number 2 comfortably. So the answer would be 3 by 4. This is how you use trigonometric limits. Now, the main weapon, okay, is L'Hopital rule. And if you know L'Hopital rule, your task is going to be very, very easy. So you can apply L'Hopital rule when I will tell you. So if FA is equal to 0 and GA is equal to 0, then limit x tending to a fx upon gx. Now you can see that it is given that fa is equal to 0, ga equals to 0, and they are differentiable. They are differentiable. Differentiable means we can talk about the derivatives f dash x, g dash x, and so on. So you can see that whenever I'm going to put x equals to a, I'll get, f a by g a, and f a is 0, g a is 0, so we'll get 0 by 0 form. So this is equal to limit x tending to a, f dash x divided by g dash x. So if this expression turns 0 by 0 form, then you differentiate the numerator, differentiate the denominator, and then put x equals to a. If it is still, if f dash 0 by g dash 0 is 0 by 0 form, continue. What does it mean? It means that it will be equal to limit x tending to a, f double dash x divided by g double dash x. So the story goes on till we get rid of the 0 by 0 or infinity by infinity form. This is called L'Hopital rule, and it is a very, very important rule. Now, for example, you have to calculate limit x tending to 0, you know, sin x upon x. Now, I already told you that it is equal to 1, but how? So if I put x equals to 0, this is 0 by 0 form. So let us try to differentiate the numerator. So the derivative of sin x is cos x, and the derivative of x is 1. So now put x equals to 0. Cos 0 is 1. So that is the beauty of L'Hopital. So now, for example, you have a situation like this. Limit x tending to 0, x square by sin x. Now you put x equals to 0, so you'll get 0 square by sin 0, which is 0. So 0 by 0. So again, you put L'Hopital rule. So what is L'Hopital rule? Differentiate the numerator, which is 2x. Differentiate the denominator, which is cos x. And now put x equals to 0. So 2 into 0 divided by cos 0, which is 0 by 1, which is 0. So this is the beauty of L'Hopital rule. Okay. So that is how we evaluate limits. Now, summary. So the kind of questions. So question number 1 can be regarding left hand limit and right hand limit. They can give you a function and they can ask you to calculate the left hand limit or right hand limit of a function at a particular point. Question number 2, they can ask you existence of limit. They can ask you whether the function has a limit at a point or not. In that case, you have to calculate the left hand limit, the right hand limit, and check whether they are equal or not. If they are not equal, the limit does not exist. If they are equal, the limit exists and it is equal to the common value. Question number 3, they can ask you to evaluate limit. Now, evaluation can be done by direct substitution. That is the most easy one. Second evaluation can be done by factorization when you have common factors and you can cancel the common factors. Third is by rationalizations when you have square roots under consideration. Fourth, we have trigonometric formulae. And fifth, we have L'Hopital. So if you know all these things, you will be able to handle any question related to limits as far as UGC NET and GRF examination is concerned. This is for the day. Thank you very much and keep on coming to our channel to watch such useful videos which will help you to ace the UGC NET GRF exam. All the best. See you next week.